I love robots. I've always loved robots. I love robots more than I love spiked lemonade. So I was so excited when I first got to MIT that I was going to be able to see and work with the truly cutting edge in robotic technology. You know, the robots that are on the cusp of taking all of our jobs and taking over the world. And I quickly discovered that the cutting edge looked kind of like this. Maybe a slight exaggeration, but I showed this video recently to an audience, and I got a really upset email afterwards from the creator of the robot who happened to be in the audience at the time. And he said, Kate, the robot doesn't always fall over. And he sent me videos of the robot not falling over. So the point here is not to make fun of the roboticists. It's not to make fun of the technology. The point is just that the public's perception of where we currently are in robotics and where we actually are is quite different. Now, that's not to say that we shouldn't be talking about what robots mean for the future of work or the future of humanity. I mean, these are things I think about all the time. It's just that I come at them from a slightly different perspective, and I want to share some of that with you here today. So here's something that I think is really interesting about robots. This is a Japanese manufacturing company. Like a lot of manufacturing companies, they haven't been able to fully automate their assembly line because humans still do certain things better than machines. So they have people working alongside robots in their factory. And they have their workers come in the mornings and warm up their bodies for their day on the assembly line by doing these exercises. And they will have the robots do the exercises with the people, with their arms, in order to be perceived more like colleagues and less as machines. Isn't that weird? Or a few years ago when Boston Dynamics, a robotics company, released this video of a robot named Spot being kicked, everyone in robotics watched this and said, wow, it didn't fall over. I wonder how many takes that took. And, more normal people had kind of negative emotions about what was happening in the video. And it got to the point where it got so much press attention that PETA, the animal rights organization, had to issue a press statement on the video. So what has always fascinated me about robots is that people, despite all knowledge to the contrary, consciously or subconsciously treat robots like living things. Now, I was at this conference about a year ago, and I was getting a spiked lemonade at the bar, and I met this guy. Let's call him Scott, because that was his name. And Scott asked me what I was interested in, and I said, I'm interested in the fact that people, despite all knowledge to the contrary, will consciously or subconsciously treat robots like living things. And Scott said, I don't buy it. And we had a long discussion for about 2 hours. I could not convince him. My kids interact with their devices much differently than I do. Of course, our generation that grew up with Star Wars and R2-D2, we might apologize reflexively when we stumble over a delivery robot on the street. But he said, new generations, they're going to grow up with robots all around them, and they will treat them like any other device. Now, sure, part of this is the influence of science fiction and pop culture. We are really primed to want to personify these machines. And part of it is the novelty. Right? When a few years ago, a hitchhiking robot got beat up in Philadelphia and vandalized beyond repair, and people were really sad about that. That might have been because no one had ever seen a hitchhiking robot before. But there's an aspect to our response to robots that goes a little bit deeper than this. It is this inherent tendency we have to anthropomorphize, to project ourselves, our human-like qualities, traits, and emotions onto non-humans. We do this from a very early age. We do it in order to make sense of and relate to the world around us. And our ability to do this is amazing. We will do this to animals all the time, of course. We project emotions that may or may not actually be there. Oftentimes they aren't. It doesn't matter to us. We will relate to things that aren't even alive, that are just created in the image of something lifelike. And we see faces in everything. We see faces in car headlights, in random objects. Faces are an interesting one because the first thing that an infant learns to recognize is a face, and it doesn't even have to be a real one. It can just be a very simple black and white image. So this is very deeply ingrained in us. And the other thing that we respond really strongly to is movement. Studies indicate that our brains are hardwired to scan the environment around us and separate things into objects and agents. And that makes sense evolutionarily. We've had to look out for predators that move around like agents. So of course we've developed this sensibility to this. But where it gets interesting is when we take the movement of an agent and put it into an object, because that starts to trick our brains into projecting intent and life onto this autonomous movement in our physical space. And so you see this happen even with really simple robots. If you take the Roomba vacuum cleaner, not the most sophisticated robot in the world, it's very useful, but it's just a disc that kind of roams around your house to clean the floors. But the fact that it's moving around on its own causes people to name their Roomba. Over 80% of Roombas have names. And I don't know what the statistics are for your regular handheld Dyson, but I guarantee you they're lower. People will feel bad for the Roomba when it gets stuck in the curtains. People will send in their Roomba for repair. I was visiting the company last year, and they have all these stories of people sending in their broken Roomba, the company offering them a brand new replacement, and people turning that down and saying, no, we want you to fix Meryl's sweep and send her back to us. So a more extreme example of this is military robots. Research has been done. Julie Carpenter and others have looked at how soldiers become emotionally attached to the bomb disposal units that they work with. They'll give them names, they'll give them medals of honor, they'll have funerals for them and get upset when they get broken. This is a pretty extreme response to a robot that doesn't look special at all. It's just basically sticks on treads. And a lot of them are even mostly remote controlled, so not even fully autonomous. So we're already seeing this response, and that brings me to an element that can enhance this even further, which is design. We are seeing an increase in biologically inspired robots. This is, again, this Boston Dynamics company that makes these very biologically inspired robots. The reason that they do this is because animal locomotion is really practical. It's a practical thing to draw on if you're trying to get a robot that can navigate different terrain. But it's also really hard to watch a robot like that and not feel like it has agency. So at the end of this conference where I met my lemonade friend Scott, we bumped into each other again. It was this robotics and space conference, and he was a space guy, but there was a lot of robotics stuff at this conference. And he told me he had seen a demo of a dragonfly robot. This picture is not the actual robot. It's just so that you can imagine. It was this very biologically inspired thing that could fly around. And Scott said that he had noticed not so much the robot, but the people watching the robot. He said they were totally transfixed. They could not take their eyes off of this thing that was flying above their heads. And he said, you know what, Kate? It made me think, maybe you're right. Maybe we are built this way. But I still don't buy it. And I said, oh, come on, man. So, we shook hands, we parted ways. We decided we would come back to this again in a few decades to see who is right. And I do think the next few decades are going to be very, very interesting to watch. Because another thing that we're seeing is a category of robots that are specifically designed to get people to treat them like they're alive. Social robots have eyes and faces, or they mimic movements, sounds, cues that people automatically, subconsciously associate with states of mind. And this works really well. So this is something that I first got interested in when I bought one of these. This is a Pleo. It's a toy that came out in 2007. I have one with me here today. I'm going to turn it on. It takes a little while to warm up because it's very old. This is Mr. Spaghetti. So I originally bought a Pleo because it's a really cool piece of technology. They have all these motors, they have touch sensors, they respond to touch, they mimic lifelike behavior really well. They have infrared cameras in their snouts. They're kind of cool. And one of the things they have is a tilt sensor, so they know what direction they're facing. And I would show this off to my friends. I would say, hold it up by the tail, see what it does. Because this is what happens if you hold it up by the tail. So it starts to struggle and cry. It mimics being in distress really well. And one of my friends held it up for a really long time, and I realized that it started to bother me. And I would say, okay, that's enough now. Put it back down. And then I would pet it to make it stop crying. And that was really weird. So I knew exactly how this robot worked, and I still felt compelled to comfort it. And that sparked a curiosity in me. So fast forward a few years, I did this workshop at a conference called LIFT in Geneva with my friend Hannes Gossert. We took 5 of these baby dinosaur robots. We gave them to 5 groups of people and had each group name their robot and play with it and interact with it. They did a little fashion show with them. And then after about 45 minutes to an hour, we unveiled a hammer and a hatchet, and we told them to torture and kill the robots. And this turned out to be more dramatic than we thought it was going to be. We had originally thought, some people would say, oh no, we don't want to do this. And some people would say, oh, it's just a robot. Instead, they all just completely refused. And so we had to improvise a little bit to get something to happen. At some point we said, okay, you can save your team's robot if you take a hammer to another team's robot. And they tried to do that. There's a little bit of footage. It's not great footage. There's no sound, but you can see what's happening. This woman is trying to hammer this robot. Oh, she's petting it instead. And then she gives up. So that's how that went. Finally, we had to threaten to destroy all of the robots unless someone took a hatchet to one of them. And this guy volunteered, and we all stood in a circle around him, and he brought the hatchet down on the robot's neck. He had to do it a few times. Everyone kind of winced. And then there was this half-joking, half-serious moment of silence in the room for the fallen robot. So that was a really interesting day. Now, this wasn't science. This was not a controlled experiment by any means. This was just a workshop at a conference. But it inspired some later research I did at MIT with Palash Nandi and Cynthia Brazil, where we used something that was less cute and evocative. We tried to use something more basic. We used these hex bugs, which if you have kids, you might know this toy. It moves around like an insect. And we had people come into the lab, smash them with mallets, and we were interested in 2 things. We wanted to know, first, would people hesitate more to hit the hex bugs if we personified them? If we said, this is Frank. Frank's favorite color is red. He likes to play. And the second thing we wanted to know was whether people would hesitate more if they had higher tendencies for empathy in general. So we did psychological empathy testing with people, and we found that people who scored low on empathic concern, they did not care much about Frank. They would just hit Frank. And people who scored higher on empathic concern, they would hesitate more or even refuse to hit the hex bugs, especially when they were personified and had a name. So this was just a little study, but it's part of this large and growing body of research that shows that we respond to the cues that these lifelike machines give us, and we respond even if we know perfectly well that they're not real. Now, why does this matter? It matters because what's happening right now all over the world is that robots are moving from being kind of behind the scenes in manufacturing, in factories, in cages, into shared spaces. They're coming into our workplaces, into our households, into public areas. So spaces where they interact with people. So we have these machines that can sense and think and make autonomous decisions and learn and move around in this autonomous way, coming into these shared spaces. And even though we know that they're not alive and they can't feel, people feel for them. And we treat them differently than other devices, and that is so important to know for technology integration. I actually think what this Japanese manufacturing company did is brilliant, and stuff like that might even work in a Western setting as well. But also, we're seeing some really cool use cases for this effect in health and education. So, for example, researchers have discovered that children on the autism spectrum will engage with robots in a way that they don't necessarily engage with people or with the other devices and tools that we've seen previously. So this is a new tool to engage children in therapy that we have not had previously. Similarly, in education more broadly, robots might be a very engaging tool that teachers can use to help engage children and engage their curiosity. There's already some very promising results in human-robot interactions showing that we might be able to use this. And then there's the Paro baby seal robot, which is a medical device. It's been around for quite some time now. It's used in nursing homes and with dementia patients. And it's very, very cute. It's adorable. It makes these little movements and sounds and responds to your touch and gives you that sense of nurturing something, which sounds a little bit creepy. You know, we're giving people the sense of nurturing something that's not alive. But it turns out that this robot has very positive psychological and even physiological effects on people. They've even been able to use it as an alternative to medication for calming distressed patients. So that's kind of awesome. Now, oftentimes when I tell people about this robot, their first response is, Kate, oh my gosh, that's so terrible. I can't believe we're living in this dystopia where we give people robots instead of human care. Now, I think that this is actually a huge problem in how we talk about and think about robots, whether that's in our casual conversation, whether that's in the news media, and even roboticists themselves will do this. We are constantly comparing robots to humans and artificial intelligence to human intelligence. It makes so much sense that we do this, given everything I've just told you about how we project ourselves onto robots. Of course we do this, right? We do this in our stock photo images. If you do a Google image search for artificial intelligence, you get a lot of images of human brains and human heads and humanoid robots. And of course, it's similar if you look for the word robot. It's a lot of human shapes. And we do this in our conversations about robots and jobs, often talking about it as a one-to-one replacement. And we do it in our conversations about intelligence and skill generally. We're constantly comparing to our own intelligence. Like, people love to ask me if I enjoy watching my child's brain develop because I'm so interested in robots. I think that this comparison really limits us in some ways. And it also doesn't make a lot of sense because artificial intelligence is not like human intelligence at all. We already have machines that are much smarter than people. They can do calculations. They can recognize patterns in data. They can beat people at games like chess and Go and Jeopardy. But on the other hand, people are also much smarter than machines. And in some cases, a lot smarter. It used to be that if you asked Siri to call you an ambulance, she would try to literally call you an ambulance. And I know Apple has fixed this by now, of course, once it became known, but they probably had to fix it manually because if you've tried to have a conversation with Siri anytime recently, you've probably noticed that she's not the best conversationalist in the world. Now, that's not because machines aren't intelligent. It's because their intelligence works very differently from our own. They perceive the world differently. They learn differently. And so to me, the question isn't, can we eventually recreate human intelligence and human skill at some point in the far future? The question to me is, why would we want to do that when we can create something different? So what if we tried on a different analogy? And it has to be an analogy that recognizes this tendency we have to treat robots like living things, which I don't think is going anywhere. But there is another analogy that is familiar to us and that changes some of our conversations in, I think, very important ways. So back to this baby seal robot, the Paro. The Paro doesn't replace human care. You don't have nurses lying down in patients' laps being stroked. The Paro replaces animal therapy. And it replaces animal therapy in contexts where we can't use real animals for a lot of reasons, safety, hygiene, even cost. But we can use the robot because it performs very similarly to an animal. It will lower people's blood pressure when they stroke it, for example. And much more broadly than just the health context, we have used animals for work, for weaponry, for companionship for thousands of years, right? We've had oxen to plow our fields. We've used horses and donkeys and camels to traverse continents in totally new ways. And the reason that we've used animals isn't because they do what we do. It's because they have skills that are very different from our own that we can use, right? We've partnered with them in what we're trying to achieve. And there's all these amazing parallels to how we're using robots in practice today. For example, here is the original aerial photography drone. This is from 1900. A pharmacist in Germany was using pigeons to deliver medicine, which is how we're using drones today to deliver medicine to remote areas. And he was like, what if I put cameras on the pigeons? Maybe they can take some aerial photos. Wouldn't that be cool? And it worked. And of course, the CIA later adopted it to try to create spy pigeons. But also pigeons have delivered mail for thousands of years of human history and let us communicate with each other in new ways before we had radio or a phone or any of those other methods. So the physicality of robots helps us extend our own physicality and our own abilities. I was sitting on a plane back when we could fly places. I was on a plane and the guy next to me was telling me that he develops these modular robot systems that go into pipes and sewers. So places where people can't easily access without having to dismantle the whole thing. But that's actually something that we used to train ferrets to do. Ferrets with their long, slender bodies, they still in some places will run electrical wire for us because we can train them to go through the pipes. And it's not just the physical abilities that we're extending, it's also our sensory abilities. This is an official United States Navy echolocation device. Back in the 60s and 70s, both the United States and the Soviet Navy started marine mammal training programs because they realized that marine mammals like dolphins have amazing echolocation systems. They can tell the difference between a BB pellet and a kernel of corn from like 50 feet away underwater. And they're trainable. So they started training them to locate lost underwater equipment. There's rumors that they did stuff like strapping harpoons to them to make them into weapons. And we have still used them. So in both Gulf Wars, the United States used underwater robots and dolphins for underwater mine detection. And they have tried to phase out the dolphins and replace them with robots, but the technology still hasn't caught up yet. Now, in some areas, the technology has caught up. This is the original sensory equipment we used to have in mines, the canary in the coal mine. So there are lots of parallels. There's so many parallels to how we're using technology today. But my point is not that animals and robots are the same. Of course, there are differences, right? You can't dictate an email to an animal. A lot of animals can kick a ball better than a robot can. But the point is that this thought exercise helps us open our minds to new possibilities. And it counteracts this narrative that robots can or will or should replace people. It changes some of our conversations. Like, you've probably over the past 5 decades or so seen headlines like this about robots taking the jobs. Robots don't take jobs. Automation disrupts labor markets for sure, but that's giving the robots a little too much agency when what takes jobs is, of course, the choices that we make. There are multiple ways to think about how we automate labor, and it's not as determined as some people argue that it is. So, for example, the United States Patent and Trademark Office has been looking into using artificial intelligence to improve the patent examination process. The problem they have is patent examiners, they sit at a desk, they get a bunch of applications, they have to look at them, look at the inventions, decide if the inventions are new. And so technically they're supposed to sift through all of the world's information to make that determination. That's impossible, of course. And so the patent office issues tons of bad patents every year that are a huge economic cost and a drag on the system. Now, they could have, as I have seen many companies do, they could have said, I wonder if we can train an AI algorithm on all of our available data to make these decisions better than a person could. Because if it's even 1 or 2% better than these patent examiners, then we don't have to pay all these salaries. We can just get rid of these people, right? That's not what they did. They said, how can we use artificial intelligence to help the patent examiners do a better job? So they started testing AI as a tool to help the examiners look for prior art, to surface some of that prior art and allow the humans to do what they do best, which is make that judgment call, that determination. So it's a small seeming difference that is actually a huge difference. Instead of asking, how do we automate away these pesky humans? They said, how can we use technology to help people do a better job and improve the system as a whole? How can we help people be more productive? How can we let the humans do what humans are good at and enjoy doing, and automate the things that robots are good at doing, which are either things that we can't even do ourselves, or things that are dirty, dull, dangerous, these rote routine tasks that people don't like doing anyway, in which case we can retrain them to do other things. So these are the conversations we should be having. And I think that thinking about robots and artificial intelligence as animals, as this supplement to human ability, really helps us rethink that technological determinism of the robots taking our jobs, and makes us understand that we do have choices. Now, I think that this animal analogy applies even more broadly than just in workplace integration. It also helps us make predictions about my area of interest, which is our social relationships. If you think about it, throughout history, we have treated most animals like tools and products, unfortunately. And then some of them we've treated with kindness, and we've given a place in society as our companions. I fully believe we're going to do the same thing with robots. We're going to treat most of them like tools and products, and some of them we're going to make into our companions. Now, we all know what my lemonade friend Scott would say to this. And this is what I want to say to Scott. Maybe you're right. Maybe once robots are ubiquitous, people will treat them just like any other device. But I just don't buy it. And I think that the research in human-robot interaction isn't just interesting and fascinating, it's also important, because we're not just learning more about the technology itself, we're learning more about us, about human psychology and human behavior and empathy and how we relate to others. So acknowledging and understanding better this social tendency that we have and how it extends to these new machines in our lives, it helps us with technology integration. It also helps us recognize some of the actual and more hidden challenges that I think we will be facing in the near future. So something that keeps me up at night is as these robots come more into intimate spaces of people's lives and homes, privacy and data security is a huge issue, but also emotional manipulation. Social robots are very persuasive. They can persuade you to do things for your own benefit and health and education. Can they persuade you to do things for someone else's benefit? I think if we can set aside some of our moral panic and technological determinism around human replacement, it helps us see challenges, it helps us see opportunities, and it helps us see our choices in this new future. And if we can think outside of the box, think about robots a little bit differently, then that helps us lean into the positives and truly focus on creating technology that benefits people. If we can do that, then I, for one, welcome our new robot partners in this future, and I look forward to working together to shaping this robotic future and making it all about human flourishing.